Today, Open Source Security is talking to Kairo, an open source software engineer. And we're here to talk about RSTUF, which is what repository service tough, I think it is. I'm super excited. Kairo reached out after one of the episodes, like, hey, we should talk about this. And I was like, holy cow, yes. So Kairo, like, tell us why you're here. What are you up to?
Well, yeah, thank you first for to invite me here, accepting me here, because yeah, I think your work here is very important for us from the open source, trying to help the community and the organizations, as we do a lot. I'm here to try to explain about a little bit about TUF, or the update framework, and what the problem that a repository service for TUF is trying to solve and help.
Awesome. Okay, so let's just start at tough then, like the update framework. Like, what is it?
Okay. Yeah, first, I always say that the update framework, or TUF, is tough, right? It's not easy
Nice.
to manage this, but when you get this, you see that it's quite fun and important for any kind of organization and open source project. So the first thing is the update framework. Actually, it was a paper that was created in more than 10 years ago at New York University. And they were researching how they could make repositories safe, right? So they focus in repositories like Debian package or PyPI and other artifacts repository that are common used by everyone. And they come up with this framework, this paper, and this paper, after a while, it become um, a reference how to secure a repository. And this is actually the TUF project. It's a graduated project under CNCF, right?
Yep, that's right.
That's cool. So this was the first approach. So the first approach, we have a specification about how clients should handle package updates. But after a while, people developed good libraries to implement TUF, like the first versions of Python TUF, Go TUF, that is used by CStore, for example. But after they solved the problem about how we interpret the specification and how we can enable implementation of TUF in different languages, right? So I was working at VMware at that time, and I came up with the idea how we can make things easier for TUF, because it's still like when you have these libraries, it's still to implement the TUF repository side. The TUF client, it's well covered by those libraries, and it's quite easy to anyone to implement a client. Of course, depends of your requirement. This is TUF. So what TUF does and what the problem they solve, the security. The research started even before SSL, right? So how we can secure the clients fetching artifacts to predate the systems or the package system safely. So the way that they do this is with everybody to do is signing package,
Yeah.
right? So we do it for years, and TUF has not done something on top of that, but use that in a better way. The thing that TUF does is like you have the metadata and quite a few delegations, and we call root the root metadata is the main and central source of trust. What we have inside of this metadata is the cryptographic keys that sign the other metadata and sign itself. So that's why TUF is quite complex, right? We don't deal directly with cryptography. We just use the cryptography to sign. TUF doesn't build the cryptography. It just uses cryptography to sign those metadata. So
yeah,
all those that are available there. So the difference of TUF, of what is for me, I try to explain it in very simple way for people to understand. What's the big difference of signing an artifact and signing the TUF metadata that contains the artifact information, like the SHA or the size of the. The big difference is that the key management.
Yeah.
right?
Yeah.
What happens if you lose a key? Maybe you are using a pair of keys and you lose this key. And what you need to do, it's simple. The solution is quite simple, right? You generate a new pair of keys, resign the artifact, publish the signature and the public key, and people can validate. But here, if you think you are breaking a little bit the trust, because I need to give to you the new public key, and you need to trust that it's me, Kairo, giving my new public key, right?
Yep.
So that's the problem that TUF solves, because the way that you distribute the trust in TUF, it's way better, and we can go more details with that. I will stop here because it's getting more and more complex. Answering your questions, we go to the better direction.
It's a complicated problem to solve. Like I understand that. And I will try to sum this up in a way to make sure I grasp what's going on. And there's some history here as well. So kind of historically, when we think of getting packages from a place, we're talking often about using like, apt-get in the Linux world. You might have PyPy, you might have whatever. And now these days, things like PyPy and NPM, they are going to like a trusted URL, and we'll put trusted in quotes, right? So as long as they control that URL and the TLS behind that URL, you're relatively confident in the connection. However, there are mechanisms that have especially been used in the past, like mirrors, right? Open source mirrors, where I have an untrusted location I am sending data to, and I've signed it with, let's say, my package signing key for RPM or Debian or whatever. And then when the clients pull it down, they can say, was this package signed with that key? And these are all like completely custom, like handcrafted solutions that only work like for Debian, only work for RPM. There's never been a way to do this repeatably, and it will say in a standardized fashion. Because if I give you an RPM and you're on Debian, you have no key information, you have no way to verify that RPM, right? Whereas TUF gives us the mechanisms to, we'll say, figure out like where the key material is, how I can acquire it, how I can trust it, make sure I'm actually using the key that was signed. Because like you said, Kairo, is how do I know Kairo made that key? And like, this is like the old GPG signing party problem, right? Of like, oh, this is my key. Is it? Like, where did that come from? So anyway, right? That's kind of that is the idea behind TUF, right?
Yes, you cover it very well, better than me trying to explain TUF. I think as much you know TUF, you get complex to explain TUF. But let me, I want to use some topics that you mentioned here. That's very interesting to understand which kind of problems TUF is solving. The first thing that you mentioned, like, okay, I have the public key and I want to verify. I want to make sure that it comes from, first, you need to make sure that it came from one specific repository, not a mirror or CDN.
Sure.
Right? And make sure that this is the artifact. Then you use this key against it. With TUF, you don't care where you're storing the artifact, because the repository where you're storing it, you don't care. It could even come back and go to FTP. Of course, don't do that, but it could work and would be secure. And the thing is about the key, right? We said about losing keys, regenerating keys, and making sure that you trust that it's my key. I would say that the SigStore solved this problem about losing keys.
Sure.
Right?
Yeah.
Because they are linked to identity. But what happens if for 24 hours, my identity was lost and someone took access to my account and he's starting signing packets with this? If you think the package will be valid and forever valid, right? And if you distribute this, even if I go to my official URL that is covered by SSL and I remove this package from there, me as an attacker, I could host this malicious package in another repository, and the signatures will be valid because, yes, I signed those.
Yep.
TUF helps with this because there are protections about the freshness of the repository as well. So you could remove the package from the TUF metadata and add the new package that you signed, for example. And even if Unataka try to give you an old package signed, it will be not trusted.
Okay. I did not know that part. That's very cool. Okay. So does TUF have some sort of public like registry of signed artifacts then? Is that how that's done?
No, there is not a public one. Any repository that is bootstrapping the TUF, they will be the initial source of truth.
Okay.
So you don't have like on SSL that you have the root. You create your root. This is something that we discussed a lot. Like, would be nice if you have that.
Yeah.
I would like to see TUF almost like a protocol, but it's a lot.
For sure. Well, and look, this is one of the complaints I see with SigStore is SigStore is completely public, right? They've got the ledger that's public. Anyone can see it. And there are many use cases that do not want a public ledger of everything that happened. And this is, I feel like it adds the complexity of TUF, but it also is a pretty big problem for a lot of organizations, right?
Yeah, that's true. And by the way, SigStore use TUF, right?
Yes.
Behind the scenes, TUF is there securing the keys as well.
It's very circular, right?
Yeah.
That's what, but I mean, that's part of the challenge with all this cryptography stuff, right? Is it's like, it's all circular, and somewhere you have to figure out like, where is the stake in the ground that everything is tied to? It's so complicated.
Yeah. After a while, I'm a maintainer of Python TUF and the author of RSTUF and maintainer as well. But after a few months working in TUF, I ended up working in total with other folks. I overlap in some security system libs too, because everything overlaps. I mean, in security, all those products will be all together.
Yep, for sure. Okay, so let's, as much as I think we could talk about TUF for several hours, let's switch over to your project, which is specifically repository service for TUF, which is RSTUF, right? Is it our stuff? I mean, I don't know how to pronounce that.
Yeah. We have a joke that we always say our stuff because we want to secure our stuff, but our stuff. Yeah.
That's awesome.
You're right.
All right. So tell us about it though.
Okay. What's this product? This product is now an incubating product under OpenSSF. Okay. So it is also, again, it's everywhere, right? TUF is on CNCF, and our stuff is under OpenSSF, what is good because it's a neutral organization. It means that it's a fully open source, not only the license, but it is there for the community. This product was with the challenge about how we can make easier to create, to create the repository side of TUF. Okay, because as I mentioned before, the client is quite easy. The libraries out there, they do a very good job. But how I integrate the TUF repository to my artifact repository, right? So I was trying to think about something really agnostic. Once a colleague of mine said that repositories are more alike than different, right? Most of the repositories, what is a bunch of artifacts inside of that, and someone is just trying to fetch something like that from it. Okay, from that I said, okay, I think it's possible to us to do something. So, but right before that, I got a challenge to implement TUF to PyPI. Okay, so there's a PEP for that, PEP for 5.8.
Yep.
And don't be scared, but it's more than 10 years old. And it's still not implemented. We are trying. But what happened is while I was implementing this, using the powerful Python TUF library, that is one of the reference of implementation as well, I got a very big PR for PyPI folks. Really, really big. And I was starting thinking how to maintain this in Warehouse. Warehouse is the platform that builds the PyPI.org. Okay.
Okay.
And this was quite big. And for them to review, they should know a little bit about, or not a little bit, a lot about TUF as well. So it wasn't difficult to get married. Imagine what I'm adding for them to maintain, like, oh, here's TUF back for 5.8, I don't know, 10,000 lines of code. And if something breaks, how we solve that.
Yeah.
So I come out with the idea to detach all these mechanisms to manage the TUF repository from PyPI. And we come up with RSTUF. And I'll explain how it solves the problem. But before, I need to highlight here that this was someone that challenged me. That was Joshua Locke. He's part of Salsa as well. He was a good mentor that I had. And he said, oh, it's very difficult to implement a TUF repository that could be used by many different repositories. And he challenged me. And on my holidays, I came up with a prototype for
Awesome.
that. It was very cool. And he liked that, and he supported me very well on that as well. So what we did was to remove all the complexity of the TUF operations on the repository side and create an API where the administrators of a repository could interact too. In the sense that they could sign the TUF metadata, they could add an artifact without adding the file itself, but giving the information of the file. Imagine that in the pipeline, you build your package or anything else, and you want to store it in the TUF metadata. Basically, you get your SHA, the JSON and of this package and the size of this package, and you tell to RSTUF, here's the package that I'm adding, and this is where the path where it will be in my, let's say, S3 bucket or HTTP server JFrog Artifactory or my OCI. Doesn't matter where you store your artifact. You just tell to RSTUF where you are storing that and what is the package information. And the RSTUF will do all the mechanism to sign the TUF metadata that, as I mentioned before, you have many delegations that will guarantee the freshness, the trust of this. And we implement other operations that are very complex, like how I create a group of people that can manage this repository. It means that these people can sign. And what if they want to use SigStore to sign RSTUF? What if they want to use an HSM key, like YubiKey, to sign that? We create all these mechanisms through an API, and we also create a CLI interface that you could use to manage that. Or, as we have the API, you could create your own interface of that. That's how we solve that. And we have actually made two main components. That is the API that you interact through to do signature, add artifact, remove an artifact, rotate a key. Let's say Josh is no longer a signer in our TUF metadata. We can remove you and add another person without all the complex steps that you must to know in TUF.
That's cool. And then the idea being, even if I sign something afterwards, I can't backdate it to gain the trust I used to have, right?
Yes, you cannot go back to that. You can, because when you have the rotation of keys, that we always say in TUF, we have the rotation of keys. The core of people will say that you are trusted or not, and you cannot back and sign that. So imagine one situation that is very common in open source product, right? I'm talking here about products like the kernel Linux or CPython. I'm right now the release manager of our product. Let's say me and you, Josh, we have a product.
Sure.
I'm now the release manager. So I sign it with my keys. In 2 years, I will handle it to you and you become a signer. To me, that what happens if I come back and sign it? Or how we tell our users which key they should trust.
Right. Yeah.
We don't have it anymore. Yeah. When you have TUF, you don't have it because the client knows which key to trust and which key is no longer.
Yeah. And that's how Tough works. It's not special code or anything. It just does it.
Just does it.
I spent a long time, I worked at Red Hat for a decade, and I was there when the Fedora keys were compromised by an attacker. And everything you're saying, like, I just have these memories coming back of like pain and suffering because we had all of these problems. And because they were all just GPG keys, like there were literally no good solutions to any of this stuff. It was miserable.
Yeah, but it's still using, I love SigStore. I love SigStore to sign Tough because it's still like, if my identity get compromised for 24 hours, what if happens if SigStore infrastructure get compromised for 24 hours?
Yeah.
How is still the artifacts that are out there are signed? People will get still confused. With Tough, you have a clear incident response when it happens. You rotate the keys.
Yeah. Well, and
the clients will get it in band. Like they will get it.
Right. And like this is not a problem with SigStore. We should clarify. Like this is how keys work. Like
exactly. It's not. I'm not here. I'm not criticizing the SigStore. I love the product.
Yeah.
I adopted it to sign our stuff and Tough metadata because I think it's better to manage keys like that.
Yeah, for sure. 100%. It's just, this is why key management is so hard. Like,
yeah,
Tough is tough. Okay.
Yeah.
All right, Kairo. So I feel like we've talked a lot about kind of how all this works, but let's go practical now. Let's say I have some sort of distribution need. Like, how do I actually make all of this work for myself? Like, what would it mean as a developer to actually like turn some of this stuff on and make use of it in my project or environment or whatever it is I'm trying to do?
Right now, actually, this week we released the first release candidates for 1.0.0.
Oh, congrats! Nice.
Right? Yeah. I think this summer we'll have the final 1.0.0, and how you could start using our stuff. Doesn't matter if you are an open source project or you are an organization, you want to secure your clients. Basically, we provide our stuff as a container services. So you need to deploy them in your, Kubernetes infrastructure or your container infrastructure. And we provide, for example, Helm charts that you can deploy your our stuff infrastructure. Okay. Basically, once you deploy it, you have the first step that we call the ceremony and then the bootstrap. What's the ceremony? The ceremony is something from Tough, not from our stuff, but we try to make it easier with the CLI. So what you do, basically, you use the CLI and you create, let's say, the group of people that are allowed to modify the Tough repository. We are talking about the root metadata, the core of and there I would recommend, for example, that you could use SigStore to be your identity to sign it. Then you have the core of people, and after that, what you need to do, you need to create what we call the delegations, where you want to store your artifacts information to be signed. Okay, this is everything in our stuff. So when you do this, basically, you can create a custom project. Let's say you have product A, product B, and you could have other people sign this product A or product B. Imagine a large organization. Or you could even let our stuff sign it for you using a key that you store in a TMS, but you can easily rotate it to get compromised, like the case you said about Fedora, for example, right? Okay, once you have these, later it's starting the operation. What is starting the operation? So the operation is you can attach your RSTUF client or just do the API calls from your pipelines. After you build your package in a trusted environment, you say, okay, now I built this package, I trust it, I want to sign. Instead to sign the artifact itself, you just send the information to the Tough metadata, and you can or let our stuff sign it by yourself, by itself, or you can have the people, let's say you have a release manager, a product manager, a product owner that must to sign your release. you can go and sign it. And our stuff will also allow you to, if something went wrong and you need to remove this artifact from your tough metadata because, let's say, even a release that you don't trust anymore because you know that it's a critical bug, you could just do another operation and remove it. It means that the clients around would not be able to download this artifact because it's compromised. And the good thing with that, you can use mirrors. Doesn't care where your artifact. You don't care about your, let's say your mirrors are not synchronized anymore, or something happens. The trust will be for all the clients, the art stuff.
Oh, I didn't even think about the unsynchronized mirror problem, but yeah, that's fair. Oh man, like this, it's so complicated.
Yeah.
All right, and I want to point out, so I'll put a link in the show notes, but there is a very nice quick start guide for running our stuff in the docs. So it sounds harder than it is. That's what I would
agree.
say.
I agree. Let me tell one. The past months, I have been advocating for our stuff in another use cases. I want to share with you too that if you and help me if they are interesting or not. Look this. Right now, we expect that the repositories out there, like PyPI or NPM, they build all the trust for us.
Yeah.
Right.
Yeah.
And they are doing a great job. Right. We have trusted publishers. We have attestations that they are providing. They are using cosign to sign packages or image. But I said that organizations can build their own trust. Right. Imagine that I can have in my organization my art stuff inside of my organization. And what I can do, let's say, a checklist to see if I trust in an external dependence or not, and add to my tough metadata and cite by myself. After I verified CVEs, if I verified that the licenses are good, if the signatures are good, I can go and cite myself. It means that all my build deployments, actually, we use our stuff to trust the upstream dependencies.
That's a cool use case. I mean, this is a common pattern we see in a lot of organizations where there are tools that can be like your local proxy, but they're hard to run. They're very expensive. And so what happens is, from my experience, is large organizations can pull this off and they might run their own mirror, but small to medium will often try and just give up and be like, whatever, it's good enough, right? And this is kind of taking that out of the picture. And now you're relying on that metadata to kind of be your root of trust versus trying to just run a mirror that's expensive and hard to keep up. So that's a cool use case. I didn't even think of that one.
Or use together, right? Because if you have your internal mirror, what happens if some attacker just attack your mirror?
That's true. That would be almost certainly ripe for attack, because my suspicion is most internal mirrors have terrible security.
And they are most of the time outdated, because sometimes they broke and stay days outdated. And people, the easy solution, we know that we work for companies that, and we have to do this sometimes in critical situation. Disable signature signing because I don't know what's happening with the keys. Or, okay, open the proxy because we need to get it out, right?
Oh, yes.
And we know it happens, right? Yeah.
Right. Yeah, everyone does it. Exactly. And it's like, let's just leave it off from now on. It'll be fine.
Yeah. Yeah, and the second use case, it's really to use to secure your deployment. So you sign, because most of people are deploying things in cloud, and you could have the clients out there, and if it gets from your local or on-prem Nexus or JFrog to get the artifact, you could secure it because you are signing it, because there are many surfaces there for attack. So our stuff, it sounds like complex to use, but I would say that it's not that.
Well, okay, look, no, I'm going to disagree with you. It's not that it isn't complex, it's less complex, right? You've reduced the complexity an enormous amount because TUF is very difficult to use. Like no one's going to deny that. This sounds 1,000 times easier. It's still not simple, but it's way, way easier. And it's almost certainly approachable by anyone willing to learn, right? Whereas I would argue like I am too stupid to ever do TUF correctly. Like I have no doubt that that is true.
I'm the same situation after 5 years working with TUF. Luckily, I'm involved in the TUF community, so they can help me all the
there
time.
You go.
So
oh,
that's the thing.
That's pretty cool. Okay, so Kairo, so let's land this plane. If I want to get involved or I want to just kind of use the product and like give feedback, whatever, like fill us in. What does it look like?
Okay, we have the RSTUF read the docs page, but I would invite you to join the OpenSSF Slack and the repository RSTUF channel, or just ask anybody in the OpenSSF in the general. They will point you to us. And I would say that also invite here people that want to participate on coding in our stuff, because there are a lot of technologies and we are looking for more contributors. And right now, OpenSSF launched a mentorship program, and our stuff is participating with a cool project there.
Nice. Oh, that's very cool. I didn't know that. Yeah. And I'll put links to all this stuff in the show notes for anyone interested. Just go check those out. We'll have links into OpenSSF in the channel and all that. So I have one last question for you that I'm curious about. So I was digging through your bug tracker, and you got a formal security audit done on our stuff, which is really freaking cool. Like how like did the OpenSSF fund that? Like what? And I will say, like to ruin the end. No serious security issues were found in our stuff, which is very well done. But anyway, like did OpenSSF cut the check for that one, or how did that work? That's cool.
That's the thing. OpenSSF funded the security audit. Actually, it was quite easy for us as an open source project under OpenSSF. The team is very great, and they did all the paperwork for us, and
nice.
the paycheck, the folks that did the audit, the export, they really did a great job interacting with us, the maintainers, and successfully we don't have any critical vulnerability found
yet.
Yet. I hope we find. I always say that it's always good to know that we have.
Yeah, for sure.
Sometimes people get scared about, they have vulnerability. No, if there is, I want to know that.
That's right.
Report to
us. That's cool. Oh, that's awesome. I'm glad to hear that. And yeah, it's a 42-page report. Like it is not a short report, but it's good. I won't say I read it, but I definitely dug through it because I've been on the receiving end of many of those many times. And it's the usual suspects, I'd say, were in yours. So, but that also means it's a well-done project, right? Because they look for the easy stuff people always screw up, which you did not do. So well done.
Yeah, I think we did good decisions in the past. For example, I like to share this. In the beginning, we were handling authentication optimization layers on our stuff API. Then we decided to drop it, and because there are better solutions out there, right? You shouldn't do a cryptography or authentication authorization if you are not is not your core.
Exactly. So, yes.
So we did it, and it was very good work.
Awesome. All right, Kairo. Well, I want to thank you. You'll have to come back sometime to let us know. Post 1.0, see how it's going. But this has been awesome, man. Thank you so much.
Yeah, thank you for having me here. Really sorry for my English or trying to explain things. Sometimes it's really complex for who is inside trying to explain things. But you did great questions for me and helped a lot.
You did great. I love it. I know way more than I did when we started. So fantastic. Thank you much.